Welcome to this IMechE webinar on the new recently published BSI ISO 1490 Adaptation to Climate Change. My name is Dr. Tim Fox, and I'm chair of the institution's Process Industries Division Board, who are hosting this event today. It's a real pleasure to be introducing Dora to speak on this topic, which is very closely aligned to our recent webinar of 2 weeks ago, discussing the findings of our own recently published report on the engineering challenges of rising sea levels. Indeed, that report, on which I was the lead author, discussed the various developments in international standards for climate change adaptation. And this webinar complements that with a deeper dive into the specifics. So it's with great pleasure that I introduce Dora. John is a chartered engineer who I've known for at least a decade through my own work on adaptation. He was formerly at Network Rail, where he headed up their adaptation activities. He's now working as an independent consultant, Dora Consulting Limited, on a host of climate change adaptation projects with organizations ranging from the World Bank, ARUP, through to the International Union of Railways. John was the lead of the international group of experts convened by BSI to write this new standard, ISO 1490. John is going to speak for around 30 minutes on this important topic, which is highly relevant to us as mechanical engineers, and in particular, extremely relevant to us within the process industry sector. He will then be available to answer your questions for the remaining 20 to 25 minutes or so. Please feel free to ask questions as we go along through the facility that's available for you online. And I'll be putting these questions to John at the end, as many as time allows. John, welcome to the Institution of Mechanical Engineers. Over to you.
Well, good day and welcome. My name is Dora, and it's a privilege to be able to talk in this webinar about climate change adaptation, and in particular, the new BSI EN ISO Adaptation to Climate Change Principles, Requirements and Guidelines. I shall call this document 1490 during this presentation. I may call it other things, but that's just setting the scene in case people join later on. I shall say it once or twice that way. I was asked in 2015 to help BSI and the International Standards Organization to help ISO draft a standard on adaptation, and became convener or the chair of an international working group co-chaired by China. 7 meetings and more iterations led to the publication of this international best practice standard in July this year. Now, what about climate change? Recent years have seen an increase in the magnitude and frequency of extreme weather events, with accelerating ice melt in Greenland, in the Arctic and the Antarctic. Also, the disappearance of glaciers across high ground around the globe. Impacts can already be seen on infrastructure and installations. Local flooding and widespread flooding, like in the Midlands and the north of England in recent weeks, affecting factories, transport, energy and communications and people's daily lives. High-level agreements, international agreements like the Paris Agreement and the UN's Sustainable Development Goals point to actions to improve resilience and adapt, as well as mitigate and reduce greenhouse gas emissions. Evidence of impacts, and this slide shows values and costs of extreme weather events since 1950, is around where you look for information from people like the Intergovernmental Panel on Climate Change. I'll leave it here a few seconds so viewers can assimilate the data. You can see there an increasing trend over the past few decades. This slide, another one from the IPCC, shows how, even if we rapidly reduce greenhouse gas emissions, as shown at the bottom left, climate change, global heating, ice melt, sea level rise will continue. CO2 levels will stabilize in 100 to 300 years, but there is so much inertia in the planet, in the oceans, that heating will continue. So how is this relevant to we engineers? We're good at solving problems. 1490, ISO 14090, as a high-level framework, has relevance to engineers when we consider the way our industrial infrastructure and infrastructure systems are impacted by, for example, directly by extreme weather events and indirectly from impacts elsewhere, for example, owing to long supply chains. Vulnerable infrastructure includes oil and gas, chemicals, petrochemicals, pharmaceuticals, food and drink, water, minerals, metals, power generation, and broader energy sectors. Examples of such infrastructure include oil refineries, gas processing and liquid natural gas regasification plants, biopharmaceuticals, pharmaceuticals manufacturing factories, food processing plants, water, wastewater processing plants, steel mills, cement factories, bulk materials handling facilities, power stations, and biogas upgrading plants. These sectors and their infrastructure are the economic lifeblood of any industrialized economy, providing most of the energy and materials vital to other sectors such as manufacturing, agriculture, building, construction and transport, as well as for the health, sustenance and socio-economic well-being of a nation's population, and disruption to their production can be of local, national and international significance. Thinking now of infrastructure systems, transport, energy, water, waste, ICT. These infrastructure services underpin education, health services, defence, government and commerce, and in turn these underpin society. The infrastructure that make these services possible is potentially vulnerable to climate change. The infrastructure in ICT, energy, water, waste, transport, fixed infrastructure, sometimes very long life infrastructure. But do you know specifically what is vulnerable? That's where 1490 can help. It offers a structured way to identify hazards, impacts, vulnerabilities, whether your organization or your clients are in a good place to assemble data, information, and turn this into knowledge, and then to systematically address these impacts and develop plans to deal with them. Indeed, many bases are covered in this ISO, including the capacity and capability of leadership and of the whole organization to gauge how their current understanding of climate change and how best to approach adaptation. Having spoken to many organizations on adaptation since 1490 was published, I see its framework touching all bases. It fills an urgent need, and if we look at the past couple of weeks at the flooding in England, and we think about the business case for action, the business case has been strong for a long time and is growing stronger all the time as organizations all over the world feel the effects of climate change. The business case has often been the most obvious to those organizations who have fixed assets. We think about asset lives, life cycles, impacts are more direct in those, and a World Bank study published in June this year said that for every dollar spent on resilient infrastructure, there's $4 in benefit in low and middle income countries. Those organizations without fixed assets are also feeling the pinch as supply chain vulnerability becomes an issue. And even organizations who do not have fixed assets and are not heavily reliant on supply chain are realizing they're at risk in some of the advice they provide to clients. For example, the $8 billion dam in the Amazon that was seen to be failing last week. Likewise, many important third parties are holding organizations accountable for acting: customers, regulators, legislators, shareholders, corporate social responsibility. And we think about Extinction Rebellion here as well. Shareholders looking at reasonably foreseeable risks, including climate change. Financiers and banks are showing a big interest in climate resilient investment in the longer term. And customers and clients are requesting better environmental standards. Inaction can lead to reputational risk. The good news is that BSEN ISO 14090 brings a framework described that sets out what international experts agreed is best practice, a best practice way of carrying out and implementing an adaptation plan. No matter what size of organization this is relevant. It could be a local football club, it could be a multinational oil and gas industry. The drafting group who developed ISO 1490 comprised engineers, climate scientists, meteorologists, sustainability professionals, and environmental expertise. We had local government expertise and others who were used to United Nations processes. I myself have 15 years experience in infrastructure and adaptation, and we know that from the depth of discussion in developing 1490, we can demonstrate that organizations using 1490 can say they're using international best practice, a recognized benchmark. Whilst 1490 is a standalone standard, it can be delivered without the need for work across other standards. It's also a framework standard. It's applicable not only to any organization, but any sector, and its structure can be adopted no matter at what stage an organization is at in climate change adaptation, from those who are just starting out to those already engaged in adaptation, or those already well advanced in their implementation of adaptation plans. It's a flexible approach that's been advocated in 1490. There's no one-size-fits-all. So organizations might find themselves moving back and forth between multiple elements of this standard. And because it works at high level, it allows organizations a choice of the how-to. It talks about what's required rather than how to do it, which is common among system standards like ISO 9000 or the ISO 14001 on environmental management systems. In fact, if your organization uses 14001, there are clauses in 14001 that require the user to look at environmental risks on the organization. 14090 fills that gap. And 14090 is action focused. It's not just about measuring risk and setting up indicators, but about managing the risk and working out how well those measures are being implemented. Key elements addressed in 1490 include stakeholders, interested parties, and how they can help scope adaptation activity. Impacts, looking at the ways that your own organization might choose to assess impacts. This standard, 1490, is freedom to look at risk assessments, vulnerability assessments, or threshold analyses. 1490 looks also organizational capacity. How fit is the organization to deliver an effective adaptation plan? And there's an early stage, which I'll talk about in a minute, looking at capacity to deliver a plan. Questions are asked about commitment and resources. And currently, I'm working in 4 sectors looking at this set of questions, including the energy and transport sectors. On dealing with uncertainty, 1490 talks about an adaptive management approach so that decisions are made looking at the impact of those decisions over time and how they can be altered and managed throughout the life cycle of maybe an infrastructure project. So they look well into the future, dealing with many of the uncertainties inherent in the science and knowledge of climate change impacts. Furthermore, the standard isn't linear. We can move around inside the standard. It's iterative and can be used wherever you are in the adaptation journey. Clauses covering leadership and looking at governance. How well is the senior leadership buying into and leading the organization in its adaptation planning? Monitoring and evaluation. There are chapters that ask the user to make sure there are implementation plans and indicators that can be monitored and evaluated over time to make sure the adaptation plan is on the right trajectory. And a very key element is incorporating adaptation into existing policies, strategies, and plans. Make adaptation business as usual. I'll go through some of the main sections in 1490 just now. I won't cover them all in detail, but the introduction part links the standard to the 2016 Paris Agreement, the goal of enhancing adaptive capacity, strengthening resilience, and reducing vulnerability to climate change with a view to contributing to sustainable development and ensuring an adequate adaptation response in the context of the temperature goal. So this links back into Paris Agreement. It links into the Sustainable Development Goals, in particular SDG number 13 on climate action. And the introduction describes the structure of the principles of value in the standard as well. Principles. There are a set of principles which cover high-level themes that are set out that can be used where there is little guidance in the standard, and indeed we use these principles as guidelines for us as standards writers when we were writing the rest of the standard. Sustainability is one. When carrying out adaptation, organisations have to think about the environment, the economy and society to try not to make things worse. It'd be very easy to adapt and emit many more greenhouse gas emissions, but we need to think about reducing greenhouse gas emissions as well as adapting. One of the main clauses in ISO 1490 is about pre-planning, preparing the organisation for the rest of the document, for adaptation planning. It includes gathering information, identifying roles and responsibilities, and making sure the resources are there. Indeed, Clause 5 says an organisation shall assess its capability to undertake clauses 6 to 10, which are the rest of the document, by identifying the moments when the organisation makes strategic decisions, determining the leadership and broader governance required, identify human and financial resources required, determining roles and responsibilities, and identifying the required levels of expertise and knowledge, as well as information and data sources. There's a lot there in Clause 5. Before you embark on the complete standard, you're required to check whether you're fit to actually deliver a complete standard. Clause 6 deals with which impact assessment methods can be used to inform the organisation about climate change impacts. And this is where organisations are given the choice to work within their own preferred ways of looking at impacts, which could be risk assessments or they could be impact assessments and the like. The assessment should be made by competent persons or competent organisations, and the standard asks that the assessment includes slow onset impacts like sea level rise, as well as sudden impacts due to extreme weather events. And we also say that the impact shall be assessed comprehensively, covering cross-cutting systemic issues. So there's quite a bit in there about thinking about systems, thinking about things outside the immediate, maybe production or activities or services that could impact the organisation, could be supply chain. And there are words in there about adaptive capacity in dealing with uncertainties. This slide shows a summary of the contents. Clause 5 is the one about pre-planning and checking whether you're fit for carrying out the rest of the adaptation plan, which is covered in 6, 7, 8, 9, and 10. Now, you may be asking yourself, what relevance is this to members of the Institution of Mechanical Engineers? So here's some detail and some questions. Do you know how weather and climate will impact your production, your activities, your services? Do you understand how weather impacts production activities and services now, in 5 years' time, 10 years' time, 50 years? This standard will help you to understand the answers to these questions. Do you already understand the impact of weather and climate over 5, 10, 50 years? This standard can help you assess your organisation to make sure all bases are covered and that best practice is being followed. What design, operation, maintenance standards are you using? Are you aware, for example, that some of the data in existing standards on environmental conditions, weather conditions, snow loading, wind loading, that kind of thing, is out of date? I'm working in some separate work with Senelec to update some of the European standards to take into account future weather patterns. I'm very aware that some of the design criteria we use are based on past standards. But do you know, if your installations are planned to be in use in 5, 10, 50 years' time, that the standards you use currently are fit for purpose? This standard can help you ask the right questions and perhaps even introduce your own standards that are related to the future climate, as some organisations have done. On case studies, I mentioned these earlier. British Standards is working with Climate Sense, which is an organisation that is part of my portfolio, to work with the transport, energy and local government sector, where leaders in those sectors are keen to gauge how well their adaptation practices are measured against international best practice. Indeed, some of the organisations are responding to the UK government's adaptation reporting power. So they're really keen to see whether their adaptation plans match the ideals of the best practice. Your organisation might be part of one of these organisations that's reporting to UK government, or you might be part of the supply chain. ISO 1490 can really help in making sure that all organisations working in adaptation use the common language, use the same language and understand the same degrees of uncertainties and look at common themes such as life cycle thinking, 5 years, 10 years, 20 years, and so on. I and colleagues are working with senior professionals to assess fitness for adaptation, mainly using the Clause 5 approach. Additional drivers, thinking about engineers. We engineers are good at solving problems. Thinking wider and thinking about the adaptation reporting power and the 90 plus infrastructure organisations who are reporting on the third round for the ARP, I think they would find 1490 of use, as would investors and people interested in climate resilient investments. I've also been contacted by one organisation who's had quite a bit of CSR pressure put on them, and starting an ISO 1490 project is demonstrating serious commitment to that company's shareholders and members. That's quite important where there's an immediacy of need to act. And we're seeing lots of interest now in resilience and adaptation planning because of the climate emergency. On systems and systems thinking, I've already mentioned society's dependence on infrastructure, and industrial infrastructure depends upon a wider system of systems. In ISO 1490, we give guidance on how to define a system. In fact, we give guidance on defining the size and scope of the problem that we need to look at, so helping users identify climate vulnerable dependencies. By putting a boundary around what we can control and examine in the sense of resilience and impact and vulnerability, we can look also at interdependencies from outside that boundary, which might be things like long supply chains, or transport systems, or ICT or energy systems. I'm nearing the end of this presentation, and here are some references that can be Googled, including a report by Dr. Fox, who's on the call with us, A Rising Sea is the Engineering Challenge, which was published 2 weeks ago, just over 2 weeks ago, and some other pointers to good practice and advice. The International Union of Railways Rail Adapt report, Navigating a Changing Climate from the Ports and Waterways Organisation, Systems Thinking for Infrastructure Planning, and some work in the railway sector looking at tomorrow's railway and climate change adaptation. Again, if these are Googled, there's a wealth of information behind these. And to finish, I'd just like to recap on some of the main points. ISO 1490, the first international standard on adaptation to climate change, has a non-linear, flexible approach that can be used at any stage of the adaptation process. It's strong on leadership, commitment and resource, looking at those early on to make sure the organisation is fit to carry out adaptation, and gives guidelines for all the areas I mentioned: pre-planning, impact assessment, capability and capacity, planning adaptation, implementing the plan, monitoring, evaluation, and reporting. The choice and flexibility, I think, enables users to tailor their actions to engineering problems, engineer solve problems. And thinking about industrial infrastructure and infrastructure systems, ISO 14090 can provide that high-level framework that engineering organizations can then use to determine where the gaps are in their resilience and adaptation planning and lead to forward-thinking, decision-making, standards and measures to make the infrastructure more resilient over time. Thank you.
Thank you, John. That was a very comprehensive run through the key points of ISO 1490, along with the insights about how to think about climate change adaptation, and of course the relevance to us as engineers, and in particular those of us working in industrial infrastructure. With regard to the relevance, John, you've clearly hit the spot with this question from one of our audience. How can I persuade my managers that we should use ISO 1490?
That's a very good question to ask, because one of the things that 1490 does at the outset is looks at the organisation to work out how well they understand climate change. But the first step is to get the managers to understand. And an organisation I'm working with just now is actually realising that 1490 can look at risks and impacts, but one of the things it does with its structure is it would enable the organisation to work out what they don't need to worry about. Because it's tempting to look at climate risk and think everything's at risk, but there are degrees of risk in different parts of the engineering sector. So what I would say is that if you're really interested in looking at adapting and making things resilient, then managers need to understand that this standard can give a structured way to eliminate some of the things you might think are at risk. So that's just one factor. There are other things we could look at as well. I mentioned in the presentation the World Bank report from this earlier on this summer that said if you spend $1 on resilience, you gain $4 in benefit. So there are things like that I would suggest that people could look at that could help them to justify use of ISO 14090. Okay,
thanks very much, John. And I guess a similar related question is from another listener saying, we don't use standards. Do we need accreditation? What do you think about that?
That's an interesting one, because you can use ISO standards, you can use standards without having accreditation. And there isn't a process available at the moment. This is a very new standard, 1490, for accreditation. As it moves on, I think the market will probably come up with ways of assessing organisations against its delivery against 1490, and that could end up with some sort of accreditation. But initially, there's no accreditation process in place. Organisations can use a standard and maybe get an independent organisation or another part of their own team to verify that they're compliant with the requirements and recommendations within 1490.
Okay, thank you. So, sort of looking at the standard itself in a little more detail, we've had some questions on some of the detail of your presentation, and one listener has asked, what are the other principles? You mentioned some principles in the presentation just now, but what are some of the other principles, John, please?
Well, there's flexibility is a principle. There are I've got a copy of the standard open, 11 principles. Flexibility is one where the organisation continually reviews, responds, and adapts to new conditions, information, methods, and solutions as they emerge. So that's one. Mainstreaming and embedding adaptation into the organisation's current systems is another. Sustainability, adaptation takes into account economic, social and environmental issues equitably. Systems thinking, climate change adaptation process include an understanding of cross-cutting issues of the organisation by looking at internal and external interdependencies and linkages. Transparency, accountability, synergy between adaptation and mitigation of climate change, subsidiarity, robustness are the other ones. Change-oriented perspective and a general clause. So there's what did I say? 11 of them.
Okay, so just moving on, there's a plethora of questions that have come in, which all have a very similar theme, which are related essentially to the interaction between adaptation interventions and mitigation interventions, and how we can optimize the integration and the relationship between those. So we've had 4 or 5 questions on that same topic, asking how we can account for mitigation in our adaptation work. Could you address that, John? That's a fairly large area.
I think the comment I can make on that is this standard is about adaptation. The principle is we need to look at sustainability. So I think my way of treating that sort of question would be, if you're forming an adaptation plan using 1490, you need to think about the other 14,000 series standards on things like measuring and managing greenhouse gas emissions. Standards, it's a choice thing. An organisation might choose to adapt and use 1490 and decide they need to follow all these principles, and there's plenty of guidance out there in greenhouse gas emission management that could be dovetailed into any sort of plan that comes out of 1490. That's the sort of way I would approach that.
Okay, and just thinking about the process that's taking place within the standard. You've mentioned a few times that it has a non-linear approach. I guess for many of us as engineers, we have a perspective on what non-linear means, and I guess it would be helpful if you could answer one of these questions that's asking exactly what is meant by a non-linear approach within the standard itself.
Yeah, that's great. When we were developing this standard, very early on, we thought, is this a management system standard? And we were thinking, well, we could have a diagram in here that looks at the sort of plan, do, check, act type process, a circular process, sequential, almost a linear process. But we decided that wasn't quite applicable to this document, because we want this document to be used by people at any stage in the adaptation journey. So we thought, well, let's write it in a way that people can dip in and dip out, because speaking to organisations that have been working on adaptation planning, and myself, I was involved in Network Rail's first adaptation plan for the adaptation reporting power about 10 years ago. Organisations like that are very mature in their adaptation. So they might look at 1490, and where 1490 recommends a risk assessment or an impact assessment, organisations might already have that sort of process in place. So it might be the organisation has to look at another aspect, which could be leadership, governance, maturity, capacity. And these are individuals, almost standalone things that can be looked at. If everything else is fine, let's look at this priority area here. That's the sort of thing I would say. You don't need to start at the beginning and work through to the end. You can look at your adaptation planning and work out where you are, and then pick out the areas where you think you might be deficient, or just assess everything and work out where your priorities and where your gaps might be.
Okay, that's really useful. Thank you, because I think that is quite a complex notion to get your head around, the non-linearity. So, just coming back to a sort of a more application focused question. I've had a question here from somebody who works in the public sector in Scotland, and where the Adaptation Scotland's capability framework is the standard tool, and they're asking what's the relevance between ISO 1490 and such a tool, such a framework, and can they use both, and how, and if so, how would it work?
That's a really good area for a case study, and maybe we'd like to speak to Adaptation Scotland on that. And I do know some people in Adaptation Scotland, but the point here is that 1490 asks the organisation to look at its capability and capacity to carry out adaptation at all sorts of levels across the organisation. The Adaptation Scotland tool is probably I think it is one that could be used to make Adaptation Scotland compliant with that part of one of the clauses. But that's only part of it. If there's another method that could be used in more detail, which there are other methods around, then it might be sensible to look at those and see if they give you better information. But the real point is that, yes, capability assessment is something that's part of 1490. We don't in 1490 say you have to use this method. We say some form of capability assessment should be carried out. So if Adaptation Scotland have a tool, that's great. That's one tick in the box.
Okay. And another question about timescales. What's the expected time frame and effort to implement the ISO 1490 standard in a typical organisation? That's quite a tricky question.
I can't really answer that. It's how long is a piece of string in some ways. But in discussions I've been having with one or two organisations, to get off the ground, you might be talking of a very short piece of work looking at Clause 5, which is about pre-planning. And that sets the scene for the rest of the document. And I've been involved in one or two workshops for that, and it might be a workshop or two with very senior people. And then 3 to 6 weeks later, you might have a report that says these are the gaps, so then you have to act on that. Adaptation is not a simple, let's do this, get this standard completed and have an adaptation plan and finish it by next year. This is a journey. And even the detail that we put into, and there's not much detail, but the detail we put into implementation and monitoring and evaluation is talking about setting up indicators for the adaptation plan that allow you to look at the trajectory. And we've really thought about adaptation as being a long life cycle type thing. And that differs. What's a long life cycle? In my experience, in my working life, I've worked on Brunel structures on the western part of Network Rail, and some of these structures go back 180 years, quite clearly long life cycle. But it might be your organisation has got a 5-year outlook, and these are things that are needing to be teased out in this structured way, in this framework, to enable the organisation to work out how best they can deal with these impacts and risks and capability and so on and so forth.
Okay. So you mentioned supply chains in part of your presentation, John, and many of us that work in the process industries are involved in very long supply chains that reach quite considerable distances overseas. So, one question I've had here is how can we assess potential impacts on supply chains and make adaptation plans?
Well, the requirements in 1490 talk about looking not just at your own organisation's activities, products and services. It talks about what might the impact be on those activities, products and services from things outside your direct control. And what we've suggested, and it's a principle as well as some guidelines, and there's an annex in 1490 that talks about this as well, what we've suggested is to look at your activities and products and services in a systemic way and work out what you are able to manage yourselves and what external influences might be, and supply chain probably fits into that external influence. And if I think about the way we have drafted this standard, we talk about engaging with interested parties, which is the term for stakeholders, really. And interested parties might be suppliers. And we're sort of guiding people to think about what might be the impact of those long supply chains be on your current operations if there's something happening across the other side of the world.
Okay, and in that regard, there's a very related question here about about the sort of context for a little bit of the context for your involvement in the work, John. It says you mentioned at the start of the presentation that you were co-chairing development of the standard with organisations from China. Do you see traction in these rapidly developing areas of the world for structured action on adaptation of infrastructure? I guess that's related to the previous question.
Yeah, that's great. Yes, I do. That sort of makes me think of one of the areas that pops up time and time again. If you're building new infrastructure, developing countries have got a golden cent opportunity to build things now, looking at the future and looking at future climate, future weather patterns, so as they have something that's built now that's resilient for 30, 50, 100 years' time. There's a bigger challenge with people in developed countries, I think, where they're looking at existing infrastructure that's been there for some time and needs to be adapted for the future. So I think there is a very clear driver for developing countries to pick up 1490 and look at their projects, programs, activities, and see how they can look at designing and building things for the future climate.
Okay, so just focusing in on the actual designing and building, we've had a lot of questions around design codes. I mean, clearly the 1490 adaptation standard is not a design code as such, but you did mention design codes, and I know that you are involved in design codes. So I'm just going to ask you one of this range of questions. So we've got the technical guidance is held within a range of specifications such as Eurocode BSEN 1991-1 for wind resistance, Eurocode BSEN 1997-2 for geotechnical aspects of design. The question is asking, will these codes be updated to reflect increased extreme weather and flooding risk, in particular coastal flooding from sea level rise?
That's something I'd like to hope that it will happen. And there have been moves, because I've been working with CENELEC on modifying some infrastructure standards, not these ones, not the Eurocodes yet, to look at the future climate. And indeed, I and colleagues have been contracted to produce guidelines on how you go about revising an infrastructure standard to take into account future climate. The challenge there is that, or one of the challenges there is that standards drafters tend to be volunteers, and the adaptation expertise resource isn't that great. So I do understand that the European Commission has been working with CENELEC to go further than just there's a handful of about 12 infrastructure standards that are subject to a current contract. I do understand that CENELEC are looking at a more comprehensive piece of work that should tackle some of the Eurocodes. But there's a point here that I don't know if I made it clearly enough in the presentation, is that if you're an organization or a client or a consultant, it's very worth sort of taking the time to look at the things like the national annexes and the structural Eurocodes and work out how applicable they are to the life cycle of whatever you're designing. I'd maybe recommend that, I would strongly recommend that these are reviewed, because you can design compliant to structural Eurocodes, but make them more resilient, make your infrastructure more resilient to the future by developing your own weather and climate criteria. And I've seen that happen in some places. There's an interesting standard called ETR 138 that the Energy Networks Association has developed on flood resilience for substations, and that looks at the future climate. So the energy sector has done that. In my time at Network Rail, which is some years ago now, we developed some clauses in drainage standards and bridge standards to look at resilience, for instance, of bridge foundations to scour, with increased flooding being the sort of future scenario. So organizations can develop their own future scenarios, their future standards, while we wait for the Eurocodes and other structural standards to catch up almost.
Okay. Yeah, I think that's a really interesting point, John, and we did touch on that in our report. I think you had highlighted and pointed us to that. So yeah, thank you for sharing that. A number of the audience are clearly not from the engineering sector. The IMechE webinars go broader than just IMechE members, and I had a question related to that. In that, one listener has asked, is the standard only applicable for engineers? So we need to clarify that. It says, or is there capacity for it to be used in other sectors when considering environmental risk assessments? So I think that needs clarifying, John.
Yeah, it's not just for engineers. It is drafted with any organisation in mind. The document, I'm just reading from it, the document specifies principles, requirements and guidelines for adaptation to climate change within or across organisations, understanding impacts and uncertainties, applicable to any organisation regardless of size, type and nature. For example, local, regional, international, business units, conglomerates, industrial sectors, natural resource management units. And I think I said in the presentation, it could be a football club to a multinational oil and gas company. And indeed, I'm actually starting to work with an organisation that owns lots of land and buildings, and it's not an engineering organisation. So I think any organisation can use 1490.
Okay, and another question sort of related to that, I suppose, which is useful to address, is that is there going to be any enforcement of the standard, and is the government going to do something about regulating and policing its application? I think that needs clarifying as well.
Well, with the current sort of regime, I think in the UK, that's not going to happen because the government has got an aversion to red tape. Enforcement would be something that might come in if there's a client perhaps lending money and saying you have to comply with this standard. Go on, sorry.
So yeah, just relating to that's a really interesting point, relating to one of the earlier questions about the appetite for adaptation and the approach to adaptation in developing economies, particularly the rapidly developing economies that are urbanizing rapidly. Are there any signs, maybe in places like Singapore, of adaptation becoming a legally binding, regulated and, if you like, policed environment?
It depends on where you are in some countries, and I believe Singapore is an interesting case in point where they carry out land reclamation in Singapore. They're saying land must be 4 meters above, I think it's sea level or some sort of benchmark for sea level. So they're catering for long term in Singapore. But I also know in some countries, I think France is one, standards like this can be enshrined in law. So that's another point. A third thing is that I understand that in European countries, standards like the structural Eurocodes have to be used when public infrastructure is being built. Now 1490 isn't a structural Eurocode, but if you're an organisation involved in using structural Eurocodes and you want to check, then here's a nice handy tool to use to look at the risks and impacts and maybe to modify your standards.
Okay, yeah, I think that's a really interesting point, and sort of related to that, I guess there's another question. We've had a number of these coming in quite rapidly now. So this listener is saying, I'm coming at this from a regulatory point of view. So they work for one of the regulators, and they're saying, how should the standard be enforced in the context of electricity network companies combating the challenge of climate change in the next regulatory price control period? So it's a very specific question, but do you have any thoughts on that, John?
Personal opinion is that this standard gives a nice framework for looking at adaptation. And it's the sort of thing I would expect infrastructure organisations who are looking at adaptation reporting, and remember the adaptation reporting is coming into the third round now, that the government has been asking organisations to volunteer to provide a report on what they're doing about adaptation. My personal view is that if 1490 is used across the infrastructure sector, then we get a consistency of language, a consistency of approach, a consistency of source data and things like that can help a consistent view going to government to say this is what adaptation means to our organisation, the electricity supply industry or the water industry, transport, energy, ICT. It's a consistency thing. that this standard could really help with.
Yeah, I think that's a really important aspect, actually, of the standard that I'm glad you teased that out, because I think, you know, within the engineering community, as a profession, we're working in lots of different sectors with our own nomenclature, our own reference to things, and I think standardizing across that would be very useful. And I guess focusing in on our industry, I've had a question from somebody in the process industries asking, with regard to the significant coastal process industries in the UK, such as oil refineries, oil terminals, gas import terminals, chemical plants, etc. Would you consider that they understand the threat and are planning for the future in your experience, or do you feel they are in many cases oblivious to this threat? What's your experience with that, John?
I think it's a bit of a curate's say. They're good in parts. Some organisations know what's coming ahead, but some have got such a short-term focus, they're not quite aware of the longer-term issues. And indeed, the rising sea levels report that Tim, that you were the author of, that came out from the IMechE 2 weeks ago, does talk about, around the coastline of the UK, look at 1 metre, 3 metre, 6 metre sea level rise, depending on the criticality and life cycle of your infrastructure. That's a message that needs to get out to the corporate organisations. That's the sort of thing that needs to be viewed at in terms of corporate risk and life cycle, and 1490 would help with that.
Yes, thank you. I think that's a good point, and certainly our own work found that there was significant lack of understanding within the process industries of the challenge of potentially quite significant sea level rises this century. So focusing in on some very specific questions, whilst we've still got 10 or so minutes to go, I'm going to ask you some very, very specific questions, John, that a number of listeners have put to us, but and clearly you may not be able to answer all these, but let's have a go at them. So if we are already contributing to ARP3, why should we use this standard as well? Do you have an answer to that one?
The use of 1490, if you're already contributing to the ARP3, would enable you to look at what's been determined as international best practice. Are you covering all these bases? Are you actually looking at technical solutions at one level? Is your leadership and governance fit for long-term reaction to adaptation? Is it looking 10, 15, 30, 50 years ahead? Or is it just looking at 5-year cycles as we see in many of the regulated industries? Questions like that would come out if you look at 1490 and look at adaptation reporting. And again, we talked about this earlier, Adaptation Scotland, looking at capacity and capability. I think that's quite important in terms of leadership and governance, because if your organisation's top management have not got climate change resilience, climate change risk in the corporate risk register, and is not sort of putting technical, financial, human resources into gathering the right sort of data knowledge and working out what the longer term risks and impacts might be. If they're not doing that, then there's a huge gap in the long term outcome of any adaptation.
Okay, and I guess a sort of fairly similar question, but let's address it. How does this relate to TCFD analysis that some businesses are already doing?
Well, I think one of the things there is, I'm not sure if everybody on the call would understand what TCFD is about, Tim.
Okay, so neither do I, John. Do you happen to know that?
Well, the TCFD is an acronym that stands for the Task Force on Climate-Related Financial Disclosure, where organisations are looking at their operations to see what impact they will have on the climate over time. And one of the things that we say in 1490 is that take a look at adaptation and resilience and impacts and the future climate around the policies, strategies, plans that your organisation has. And if TCFD is part of that, then I think it fits in very well.
Okay, and then coming out to a much more broader question, which I think references some of the earlier discussion we had this afternoon. It's relates to the interdependencies throughout organisations, and I think it's worth just addressing again, John, how does the standard help understand interdependencies throughout the organisation and indeed across sectors?
I think that's where we suggest looking at things in a systemic way and understand the annex. The annex that talks about systems thinking gives a guideline on activities and parts of processes, I suppose, that can be drawn up to show where things interact, and then working out from that what are the priority interactions. One of the things I see all the time when I work in resilience and infrastructure planning is that we tend to focus in silos on our own activities and products and services. These can be very much impacted by our suppliers. I did some work pre-HS2 the other year looking at systemic interdependencies from energy, from other transport and HS2. And we look at things like, if I've got a process here that requires electricity, how robust is that electricity supply chain? Do we need to change the contract with the supplier? Do we need to dig into the supplier to see what they would do if this scenario came about? So thoughts like that go through my mind when I think about interdependencies and the guidelines that are in 1490.
Okay. And one very last question, John, which I think is quite interesting and takes us in a slightly different perspective, is many of the approaches to adaptation are good at responding to emergent risks, but they often remain silent on emergent opportunities. Does the standard recognise the importance of emerging opportunities to adaptive planning?
Yes, it does. We did talk about risks and impacts. In fact, one of the reasons we chose the term impacts was because there could be a positive opportunity with adaptation in terms of looking at future climate and look at business opportunities. So adaptation might be about exploiting opportunities rather than mitigating or reducing negative risks, because there are positive risks as well.
Okay. Thank you for that positive and optimistic note. And I just absolutely final. I've got one more that's just literally come in that I think is really quite important to address, particularly for the engineering sector. It says, is referring it to as 1490, which I keep doing, rather than 14,090, a slip of the tongue, or is that what it is commonly referred to as? So I think there's a point of clarification, John.
Yeah, it's 14,090, but it's a bit of a mouthful. 14,090, but in the standards community, I was with an ISO strategy meeting the other day, and we talked about this as 1490. We talked about 1467. We talked about 14,001. It's not slip of the tongue. It's just it seems to be what we're commonly referring to it as.
Okay. Well, thank you very much, John. So, on behalf of the Institution of Mechanical Engineers and, in particular, the Process Industries Division Board, who've hosted this webinar today, I'd like to thank you, John, for your talk and the detailed insights that you've shared with us on this increasingly important topic. We see the significance of climate change around us every day, both in terms of its technical implications, but of course the broader socio-economic and political implications taking place as it takes its place in society. And of course, I'd like to thank you, the audience, for listening and participating. I do hope you found it a really useful webinar today, and I encourage you to sign up for future IMechE webinars. Thank you very much, and goodbye.
Thank you, Tim.